Hello, geometry students. I'm coming to you from ninth period today, trying to get this key up on the Canvas site for you so I can go to the play tonight. So I'm going to do my best to go as quickly through this as I can. If you have any questions, don't forget you can always pause the video or rewind and replay things over and over if you need to hear something a second time. You'll notice that the Smartboard document I'm using does not look exactly like your paper because I wanted to blow up some of the pictures so you can see them a little bit better. So I've made the pictures a little bit larger. Here we go with question number 1. It says, name the following for circle P. So we see circle P off to the right, and it wants us to name a minor arc. A minor arc has to be less than 180 degrees, and it takes any two letters. Any two letters. The smallest minor arc I see is from A to D. That is a minor arc. That is minor arc AD, and I would write that as AD with an arc over top of it. That is minor arc AD. Obviously, there are many more. You could use DE, EB, BC, CA, AE. That's about all of them that I think I can see. 1B says name a semicircle, so it has to be halfway around the circle. We do need to dictate which way we go. So if I start at A, and I'm going to end at B, and I'm going to go along the left side. In order to name that left semicircle, I do need 3 letters for any semicircle. A is where it starts, C is what it goes through, and B is where it ends. So semicircle ACB. The next one is a major arc. A major arc, a lot like a semicircle. A major arc has to be greater than 180. So if I start at A, and I want to go all the way around past 180, all the way to E, if I want to name that major arc right there, I have my 2 endpoints. A is an endpoint. Pick a point that it goes through, so it goes through maybe B, and it ends at E. So that is major arc, ABE. And part D says name a chord. I only see one chord in this. Actually, there are 2. One chord is actually the diameter. That is a chord. The other chord connects point D with point E along the circle. It is a line segment, so DE, line segment DE. That is question number 1. A, B, C, and D. And then we also have this extra little B that we have, and it wants us to find the distance from A to B. Now I know a lot of you ran into some issues because you were having a hard time distinguishing what point B was. So let me show you some dots that might help you. Point D is where the little circle and the big circle intersect. Point B is where segment AD, that radius, meets the little circle. So right there is B. And then obviously E is over here. So when I look at the big circle, AE is a radius. It's 10. AD is also a radius. It is also 10. So from A to D, that is 10 because it's a radius. Now, with that being said, I'm going to move the red out of the way, and we're going to take a look at the small circle that has radius 3. So CD is 3, so DB back the other way is also 3. So that means from B all the way to D, from B to D, B to D, that distance will be 6. All the way across that circle has to be 6. Now the question asks us if we can find this piece right here, the AB. So I'm going to call it X for right now. Well, I know this. I know that AB, which is X, plus BD, which we said is 6, has to equal the whole red segment AD, which is 10. And then just a real little bit of algebra 1 here, subtract 6 on both sides, and AB's distance is 4 units. It's 4 units. So that takes care of question 1. Question 2 says for circle D, NL is equal to 18. So let me draw this on here. NL, so from N all the way through to L, that distance is 18. The measure of arc NM, so N to M right here is 75 degrees. And L to K down here is 70 degrees. And it wants us to find some of the following things. So the first thing I'm going to do is I'm going to take a look at this, and I'm actually going to discuss a little bit this NL. If that whole distance all the way across is 18, the diameter is 18, that means each radius is 9 apiece, because 18 divided by 2 is 9. So I'm actually going to label this as 9s. So let me put some 9s in here. This is 9. This segment here is 9. This segment here is 9. This segment here is 9. And this segment here is 9. So I have a whole bunch of 9s. All of those radii are all 9s. So what does part A ask us? It wants us to take a look at this picture, and it wants us to find the measure of angle NJL. I'm sorry, arc NJL. So N, from N through J, all the way over here to L. So I'm looking for this great big arc over here. So this great big huge arc is made up of a point N and L going through J, and it is going all the way across the diameter. So that would be 180 degrees. Yeah, 180 degrees. Okay, let's take a look at NKM. NKM arc. NKM, here's M, here's K, here's M. So I have to go all the way around this thing. So go all the way around except for that one little piece that I know, which is 75. So I will take 360, the distance all the way around the circle. I'll subtract 75 from that because the red arc at the top I do not need. And 360 minus 75 is 285 degrees. Will be my final answer, 285 degrees. Okay. Let's take a look at C. C wants us to find the circumference of D. Well, the circumference of D is just the diameter. I know this formula. Circumference equals pi times the diameter. Well, the radius is 9, so the diameter is 9 plus 9, which is 18. So the circumference is 18, the diameter, times pi. So 18 pi is my diameter. If you wanted to see that as a decimal, you would be able to take 18 and multiply it by 3.14, and I could turn that into some sort of a decimal. So what does I look at arc length for D? It's found arc length Kn. Alright, so I really need to find for Kn, here's what I'm looking for. I am looking for Kn. So here's Kn. So I need to know this angle right here. I need to know how many degrees is that angle right there in the middle. So how many degrees would that thing be? So the best way to find that is to take a look at the arc that is 70 degrees. Tells me that the interior angle, right there, that called central angle. That central angle is also 70 degrees. So if I think now about the straight line from N through L, straight line is 180 degrees. This central angle is 70 degrees. So that means that my central angle here in green is 180 minus 70. So 180 minus 70 tells me that 110 degrees. So right here in the middle, right where this green is, this angle is 110 degrees. It's 110 degrees. So the formula to find arc length is central angle, 110, out of 360. That tells me the proportion of the circle that I am going to use. I am not going to use the distance around the circle for a whole 360 degrees. I only care about 110 out of those 360 degrees. So I do 110 divided by 360, then I multiply it by the circumference, which we said was 18 pi. If I type this all into my calculator, 110 divided by 360, and then I multiply it by 18 and I multiply it by pi, rounded to the nearest decimal point, you should get 17.28. 17.28. And that is rounded to the nearest hundredth, to the nearest 2 decimal points. So let's get rid of all that green. Now let's move on to part E. It says find the area of the sector. Well, if I want to find the area, I better find the area of the whole circle. The area of a circle is pi r squared. So the area of our given circle is pi times 9 squared, which is 81 pi. So that is the area of the entire circle. But I don't need the entire circle. I just need the part that is sector KDL. I need this sector right here. And if I want to find that area, I will do the same concept as I did in D. I will take the central angle. In this case, you can tell that central angle is 70. The central angle, 70. Divided by 360, because I don't need the entire circle's area. I need a proportion of it. So 70 divided by 360. And I multiply it by the area, which we said was 81 pi. That is the area of the entire circle. Leave in terms of pi just means in my calculator I'll do 70, divide it by 360, and then multiply by 81. And I would get 15.75 pi. And again, if you wanted to see that as a number, I would take 15.75 and I would multiply it by 3.14. That takes care of question number 2. Question number 3 says, find the radius and diameter of a circle whose circumference is 32 pi meters. Okay, so the circumference we know is pi times diameter. So if this circumference is 32 pi equals pi times the diameter, and I divide both sides by pi, and I can see that 32 equals my diameter. And I know there is a relationship that it takes 2 radii to equal 1 diameter. And if the diameter is 32, and I divide both sides by 2, the radius has to be 16. So the radius is 16, and the diameter is 32. Question number 4 says in circle L, the measure of angle the measure of angle QLN. QLN. Right here, this angle is 2x minus 5. Find x. So 2x minus 5 equals how many degrees? How many degrees will that equal? Well, there are a few things that I need to look at. First thing I need to look at is I need to notice that I have a diameter with a 90-degree angle. So I know the diameter makes up a straight line. That's going to be 180 total degrees. 90 of those degrees you see right there with the blue. The red angle is 2x minus 5. And then angle MLQ. Angle MLQ is the same as angle PLO, because they're vertical angles. Well, then I need to know what is the angle of, or what is the measured angle PLO? Well, if the arc is 37 degrees, then the arc is equal to the central angle. So that means my central angle here is 37 degrees. And my central angle here is 37 degrees. And actually this arc over here is 37 degrees. So all of those 37 degree arcs, 37 degree angles. Well, this now helps me out immensely, because now I know that 2x minus 5, this angle, can be found. So let's think again about the blue line. It makes up 180 degrees. So I have 180 degrees as the blue line. But I need to take 90 away from that because of the right angle. So that leaves me with 90. And then I need to take 37 away from that because of my angle up there, MLQ. So that leaves me with 50, oh, I'm sorry. Minus 90. So 180 minus, we'll find 90 minus, that is 3. So that equals 53. So this degree measure right here is 53 degrees. That's what that arc has to equal. So that'll be 53 degrees. And then I just have to solve this using some algebra 1. Add 5 to both sides. 2x equals 53 plus 5, which is 58. Divide by 2, and x is equal to 29 for my variable. X is equal to 29. Number 5. Circle O says the measure of MON, angle MON, right in here, MON is 60 degrees. It says that KN is a diameter. If the measure of LKN is 40, what is the measure of arc LM? That's what I'm looking for. All right, so let's first take a look at, I have a central angle of 60 degrees, which tells me that my arc from M to M is also 60 degrees. Right, that is the relationship between a central angle and an arc. Then I have this inscribed angle. I have the inscribed angle that is LKN. And there is a rule that states that an inscribed angle is half of the intersected arc. So that means the arc from L all the way around to N, that big arc, has to be twice the interior angle. So LN's arc is going to be twice as big as its inside angle, so twice as big as 40. So that arc is 80 degrees. Well, now if I have that big arc LN, then it's easy to see that big arc LN is actually just two small arcs added together. It's arc LM and arc MN added together. So here's my equation. Arc LN, I just said, was 80 degrees. Arc LM, I'm trying to find. Arc MN, we found right at the beginning, is 60. So I can subtract 60 on both sides. Arc LM, 80 minus 60, is 20 degrees. It is 20 degrees. That takes us through page 1 of the practice. Moving on to page 2, questions 6, 7, 8, and 9. Question 6 says find x. So we're going to find x here. I want to look first at this big triangle. I have this nice, beautiful triangle here. Let me outline it in red. And this triangle is made up of a tangent line. So this bottom right here, I'll call this side A. A is tangent to the diameter. So I can see it's a diameter because it goes right through O. So the side A is tangent to the diameter, and we know that it says that anytime you have a tangent, it is always 90 degrees to a radius or a diameter. So now looking at my triangle, I have a triangle that has a 90 degree side, or a 90 degree angle, a 51 degree angle, and an x degree angle. And I know that the sum of the angles of a triangle have to be 180. So let's add the angles up. X plus 90 plus 15. Now that would be x plus 105. And we know that the sum of the interior angles has to be 180. Subtract 105 on both sides, and x equals 75 degrees. That is not right. Let me go back. I'm sorry about this. I did 15. X plus 51 plus 90. That looks better. X plus 51 plus 90 has to equal 180 degrees. So that is 51 and 90 would be 141 equals 180. This is going to look much better. Subtract 141 and x is equal to 39 degrees. That looks much better. 39 degrees for angle x in question 6. Question 7. Question 7, we want to find the perimeter. Perimeter is add up around the outside. I'm just going to add all of these values up. That is a inside circle inside of a triangle, and I know that there is a relationship to tangents. So any two tangents that intersect are equidistant from their points of tangency. So if QT is 12.5, then QU is also 12.5. They have to be equidistant. If PT is 19.7, then PS is also 19.7. And if SR is 33.6, then UR is also 33.6. In order to find all the way around, I take all of these numbers and I add them up. So 12.5 and 12.5 is what, 25? Plus 19.7 and 19.7 is 39.4. And 33.6 plus 33.6 would be 67.2. And then I have to add all of these things together. Well, 0.4 and 0.2 is 0.6. At least I have that. And then 25, 39, and 67 add up to 131. So 131.6 would be my perimeter all the way around that thing. Question 8. Question 8 says that CG, so CG is 5x plus 2. And GD is 7x minus 12. And we want to find x. Well, there's a property that says that if a chord is perpendicular to a radius, then it is also not just perpendicular, it is the perpendicular bisector. It's perpendicular bisector. That means 5x plus 2 has to equal 7x minus 12. I'll subtract 5x on both sides. I'll add 12 to both sides. And then divide by 2. And I get x to be 7. Question number 9 wants us to find C. Now, C is this whole distance. That's C. So what I'm going to do is I'm actually going to find half of C first. I'm going to call it x. I'm going to call this x. I'm going to find x first, and then I'll double x to get C. It tells me that D, this distance right here, is 1. I'll put a 1 there. And it says that R, this distance over here, is 6. So I'll put a 6 there. All right, how do I find x? That is a right triangle. So that means a squared plus b squared equals c squared. So that means x squared plus 1 squared equals 6 squared. Be careful which side you make the c. Remember, c is always the hypotenuse that's across from the right angle. So this is x squared plus 1 equals 36. Subtract 1, and x squared equals 35. And then I take the square root, so x equals the square root of 35. It's just under 6. It's probably like 5.8, something like that. 5.8 or 5.9. I'll leave it as the square root of 35. So I told you right at the beginning that x was only half of the distance I was looking for. C is twice as big as x. Well, if x is the square root of 35, then c is equal to 2 times the square root of 35. And you're all done. C equals the square root, C equals 2 times the square root of 35. Let's move on to questions 10, 11, and 12. Question 10, 11, and 12 deal with the angles and their relationship to the respective arcs. So, an angle that sits on a circle, like angle A does, is half of its intercepted arc. So I have to do 106 divided by 2, and I get 53 degrees. Question 11. B is going to be equal to half of A. So A divided by 2. I need to find A. So A is found by knowing that there are 360 degrees in a circle. So if I tell you that this is 128 degrees, and this is 134 degrees, then what would A have to be in order to get to 360? Well, I would do 360 minus 128 minus 134, and I would find A to be 98 degrees. And then I said that B, because it is on the circle, is half of A. Well, now I know A is 98. So half of 98 is 49 degrees. Question 12. Question 12 tells you that, it shows you that a tangent line is running into a diameter of the circle. And we know that that has to automatically be 90 degrees. So X is 90. That's true for all tangents. Now to find Y, I just think about this circle as being this arc, which is 182, plus Y. And a whole circle has to add up to 360. So when I take 360 and I subtract 182, I get my answer of 178 degrees. Let's take a look at question 13. Question 13 has a triangle in it. So let's think that we're probably going to use something that deals with a triangle. And I have this arc up here that is 96 degrees, which means that an angle, if I think about angle F is on the circle, so it is going to be half of the arc. So half of 96 is 48. So angle F, 48 degrees. Now I have a triangle. That triangle has to add up to 180. So if I do 180, and I subtract 48, and I subtract 55, I would get angle E, which is 77 degrees. So this is 77. And the last thing it wants us to find is it wants us to find arc EF. So from E to F, this arc has to be twice as big as its inscribed angle. Well, its inscribed angle, if I take this arc and I follow it back, you'll see that the inscribed angle is 55 degrees. So I'll take 55 degrees and I will multiply it by 2 because the arc has to be twice as big. And 55 times 2 is 110 degrees. And the last problem, question number 14, wants us to find angles A, B, and C. So I have a diameter, and I have an arc that's 70 degrees. So if I have arc AC is 70 degrees, then angle B, which sits on the triangle, has to be half of that. Half of 70 is 35 degrees. And that helps me. And then I have a diameter. So if I think about the arcs here, if I have a diameter, arc, semicircle C all the way around to B is 180 degrees. Which means arc AB, if I do 360 minus 180 minus 70, this tells me that this has to be 110 degrees. So 110 degrees, angle C is opposite of 110. So if I do my 110, it has to be half its size. Take half of it, I get 55. And then to find angle A, I just deal with a triangle. I know that angle A plus angle B plus angle C is 180. So if I take 180 and I subtract the 55 and I subtract the 35, I get 90 degrees. So angle A is 90 degrees. Moving on to page 3. Question number 15 says in circle B, the measure of angle ABC is 30. Okay, so this angle ABC in here is 30 degrees. So if the interior angle is 30 degrees, then arc AC is also 30 degrees. So that's perfect. That helps. Now, it wants us to find the measure of angle CDA. If you think about CDA, this angle is back here. That's just what we were talking about. An angle that is inscribed, that sits on the triangle, or on the circle, is half of the size of its arc. So the measure of angle CDA is half of its arc. It's half of 30. So it is 15 degrees. 15 degrees. Let's take a look at 16 and 17. 16 and 17 deal with finding angle measures of secants that cut through a circle and intersect. So we have two different situations. In 16, they intersect outside, which tells me that the angle is equal to half of the difference of the two arcs. And then in question 17, they intersect inside, so it's half of the sum of the two arcs. So I have to do half of arc 1, so AE, minus BD. That will give me the measure of angle BCD. All right, so let's take a look at this here. Well, arc AE is easy. It's given. That's 120 degrees. But arc BD is not given. So I'm going to have to find it. And I'm going to find it because I know that there are 360 degrees in a circle. So I'm going to take my 360 degrees. I'll subtract 110. I'll subtract 120. And I'll subtract 80. I'll subtract all those numbers away, and I'll find out that that arc is equal to 50 degrees. So the measure of angle BCD is equal to half of 120 minus 50. So that is half of 70, or 35 degrees. Now, when the angle is formed by arcs on the inside, then I add the arcs together and divide by 2. So I'm not going to find angle 5 yet. I'm actually going to find angle X. Because angle X, I know the arcs, 66 and 50. So angle X is equal to half of 66 plus 50. So X is equal to 58 degrees. And this is 58 degrees. Now to find the measure of angle 5, measure of angle 5 plus 58 degrees make up a straight line, so it's 180. When I subtract 58 degrees on both sides, the measure of angle 5 is 122 degrees. So the measure of angle 5 is 122 degrees. Question 18. Arcs AB, BC, and CD are all the same measure, so I'll call them X. Measure of angle E is 40. And it wants us to find the measure of angle ABD. So ABD. That angle right there. Well, I know because that angle sits on the circle that the measure of angle ABD is half of the arc AD. So I just need to find what arc AD is equal to. All right, so this is where it gets a little tricky. This one is a little tricky because all the way around the circle has to add up to 360. But I have three pieces that I already know are called X. So this arc right here, AD, is equal to 360 minus 3x. This is arc AD. So now let's use our 40-degree angle. I know this, my 40-degree angle is equal to half of the difference of my two arcs. So it's half of x, which is right here, BC, minus the blue arc, AD, which is 360 minus 3x. All right, so I'm going to do a little bit of algebra on the right side and clean this up a little bit. So 40 equals 1/2 x minus 360 plus 3x when I distribute my negative sign. I'm going to get rid of the fraction by multiplying both sides by 2. 80 equals, the 1/2 is now canceled out. So I have my x and 3x, which is 4x. And my minus 360. I'll add 360 to both sides. So 440 equals 4x. So that means x is 110. All right, so x is 110. So that means this is 110, and this is 110, and this is 110. And 110, 110, and 110 would be 330, which means this little angle in here, this little arc, has to be 30 degrees to make it 360. Oh, so the measure of angle ABD, as I stated right at the beginning, is half of arc AD. Well, AD is 30. So that is half of 30. And half of 30 is 15 degrees. So the measure of angle ABD would be 15 degrees. All right, question 19. Now, question 19 could get really nasty, but you're going to notice something here in a second that makes this really, really nice algebraically. So when two chords intersect inside a circle, there's a relationship that says, we said A times B equals C times D. So it is the pieces multiplied together of one chord will equal the pieces of another chord multiplied together. So x times x plus 2, x times x plus 2 will equal this piece, 2, times this piece, x plus 2. Now, the algebra person in me says go ahead and distribute the x and get x squared plus 2x, distribute the 2 and get 2x plus 4, set it equal to 0, and factor, and all that fun stuff. But actually what I'm going to do is I'm going to divide both sides by x plus 2. Because x plus 2 divided by x plus 2 would cancel. And on the right side, x plus 2 divided by x plus 2 would cancel. And I would be left with x on the left and 2 on the right. So x has to equal 2. If you did all the distributing and foiling together and setting it equal to 0 and factoring it back out, you would end up with x equal 2 as well. Question number 20 says find BC. Find BC. So So BC, let me take a look at this. B to C is going to be x plus 5. That's where I need to go. I need to find x. So I have a tangent line, and I remember this one. This one showed up, and it says the outside piece times the whole piece. So x times the whole piece, x plus 5, is equal to the outside piece, 6, times the whole piece, 6 on the other side. So now I am going to have to do this distribution. So this is x squared plus 5x equals 36. Let's get it set equal to 0. X squared plus 5x minus 36 equals 0. Factor this thing down. Two things that multiply to give me 36, but subtract to give me 5 are positive 9 minus 4. So if x plus 9 is 0, that means x could be negative 9, or x could be positive 4. It would be one of those two answers. Since we can't deal with negative values for distance, negative 9 is not an option, so my only option for x that makes sense is 4. So that means BC is equal to 4 plus 5, which is 9 units. BC is equal to 9 units. Question number 21 says find A and B. So this is a challenging question. This is a challenging question because I have this equilateral triangle. And if you remember back to early in the year when we talked about equilateral triangles are also equiangular. So that means the three angles are always 60 degrees. So B is 60 degrees. So we have a 60, 60, and a 60. And then I can think about the arc that's made. So the arc, AB, is the arc is twice as big as the inside angle here. So if I follow those back, arc AB, which is A degrees, has to be twice of the angle. So if the angle is 60, 60 times 2 is 120 degrees. So that is 120 degrees. All right, question 22. The angle on the outside, they meet on the outside. So this angle, 30 degrees, is equal to half of the difference of the two arcs. So the arcs are 90 minus 2x. So algebraically, the easiest way to go about this is multiply both sides by 2 first. So 60, and half times 2 is 1. So now I'm just left with 90 minus 2x. Subtract 90 on both sides, I get negative 30 equals negative 2x. Divide by negative 2, and I get x to be 15 degrees. So x is 15 degrees. All right, the constructions. First of all, find the center. First thing I'm going to do is I'm going to put in any chord that I like. Just put a chord in that thing. And then I'm going to do a perpendicular bisector to the chord, because the perpendicular bisector to the chord would be a diameter. So, just make sure I move her halfway. Make an arc. To the other one. Make an arc. And then I will connect the arcs. All right, so that's my first one. So let me kind of dim these down again like we do in class. Get those construction marks out of our way a little bit. All right, so I have my first diameter. And now if I want to find the center of this thing, I want to cut my diameter in half. So if I want to cut the diameter in half, I just make sure I'm over halfway. Make an arc. Jump to the other side. Make another arc. And then I connect the two arcs. So connect right through there. So again, let me dim these things down a little. So you can see where my two diameters intersect. This is the center of my circle. Now, I will warn you on the test. It says that you also have to put a square in this. So I'm going to go ahead and show you how to put the square in right now, just to kind of help you out. The square in this would mean connect the ends of the diameters into a square pattern. So if I connect that is how you put the square into that. That is on the test. That is a promise. All right, question number 24. Those of you that did 24, I apologize. Trying to do both of these on the same picture is really, really tough. So actually what I'm going to do is I'm going to do them in two separate pictures. So you can see one of them done, and then I'm going to clear it and go to a blank triangle, and then I'm going to do it again. So we're going to get a chance to see them both. So the first one I'm going to do is I'm going to inscribe a circle. I'm going to put a circle inside of this triangle. So in order to put an inscribed triangle, I have to do angle bisectors. I have to do some angle bisectors. So, angle bisectors. Give yourself an arc to start with. Go to the points where the arcs cross. See where these two things cross one another. And then I connect there's my angle bisector. So let me make my construction marks a little more faint, just so they don't bog us down. So there's my first angle bisector. My second angle bisector, I'll take another angle and I'll do the same thing. And there's my second angle bisector again. Make these a little more faint. So it's a little bit easier to see. So this is my center. So when I want to put my circle inside of this triangle, this becomes my center. And I will open this thing up until it touches one side, so about right there. And I go around the inside. And it should touch something like that. So you'll notice that it's really, really close. Remember, I'm not going to be grading this to see how perfect your circle is. As long as I can see that you were doing two angle bisectors correctly, I'll be good for that. All right, so I'm going to change the page. I'm going to clear all this stuff out because I want to do this problem again. This time, I want to circumscribe. A circle means I want to put a circle around the outside, which means I have to do perpendicular bisectors. I'm going to do two sets of perpendicular bisectors. Well, I've already done some perpendicular bisectors today. So the first one is make sure you're over halfway. And put an arc. Go to the other side. Put an arc. Whoa. All right. And that means I want to make these things a little bit more faint. So when I connect these with my line, should be something close to that. There's my perpendicular bisector. And then I'm going to do this again. So, I don't know, let's use this side. Make sure I'm over halfway. And put an arc. Then I jump to the other side. Put an arc. And we said that we want to a little more down. Now I want to connect these arcs. And I notice that they cross outside. That's okay, because I want to draw a circle that goes around this thing. So that is the center of my circle. And I will open this thing up to one of the points. That's pretty close. And as I draw my circle around, you'll notice it's not perfect, but it's really, really close to hitting all three of the points of the triangle. That is circumscribing the triangle, putting all 3 points on the same circle. So I hope this is beneficial. I hope this is going to help you. Don't forget your test is tomorrow. If you would like to prepare a note card or a page of notes, I highly recommend having those ready before you come in and take the test. Happy studying.